What's up guys, and welcome to this tutorial. We are going over the 2018 IEB Matric Maths exam. In this question we are doing, in this video we are doing question 7, which has to do with algebraic equations. Okay, so yeah, let's get into it. So it says the roots of a quadratic equation are given as 5 minus square root of 2 and 5 plus square root of 2. Determine the equation in that form. Okay, so when it tells you what the roots of something are, it's basically saying that x equals 5 minus square root of 2 and x equals 5 plus square root of 2. Okay, so that's where we're going to start. Okay, so this is A. So we're going to start off with x equals 5. And we can just say that that's plus minus the square root of 2. So what we can say is that x minus 5, let's leave the positive, plus the square root of 2, okay, times the next one, x minus 5, and this time we take the minus square root of 2, must all equal 0. So all I did was take this to the other side. Okay, now we have to just multiply these things in. So the first one is going to be x squared, and then I'm going to multiply x by this bracket right here, so that becomes minus 5x. Putting this minus in, it's going to be plus the square root of 2x. Okay, now I'm going to multiply this bracket here with that, so that's going to be minus 5x again, and then putting that multiplying that minus in, that's going to be minus the square root of 2x, and then I'm going to multiply the last two brackets by each other. So what we have is it's going to be a minus times minus, which is a plus, and that's just going to be 5 plus the square root of 2, 5 minus the square root of 2. Okay, so that's what we're left with, and that's equal to 0. So what I'm going to do is now that becomes x squared, that cancels, and then I'm going to cancel these two, so that's, well, I'm going to add them, which is minus 5 plus minus 5, which is minus 10x, and these two cancel. Okay, and then I'm going to, this is just a number, and this is also just a number, so I'm going to plug that into my calculator, and I get that that is plus 23, and that's equal to 0. Okay, otherwise, I mean, this is quite easy to multiply out as well. That's just the difference of 2 squared, so it's going to be the first thing squared, which is, let's do it like this, which is 25, minus 2, the square root of 2 squared, which is 2, which is equal to 23, which is what my calculator got. So that's not too hard either. Okay, so basically we have the answer. So that's the answer, and we have it in that form where a equals 1, b equals minus 10, and c equals 23. Okay, so the next question, part B, says the equations x squared plus ax plus b equals 0 and x squared plus bx plus a equals 0 both have real and equal roots. Okay, and we have to solve for a and b. Okay, so the first thing that we have to note is that for real and equal roots, we can say that the quadratic must be a perfect square. Okay, so that's quite important, because therefore, if we look at the first equation, we can say that x squared plus ax plus b is equal to 0, right? That's our first equation, and for it to be a perfect square, what we know is that x plus the square root of b must equal 0. Okay, because basically we take the first thing square rooted and the second thing square rooted, and squared gives us a perfect square, right? So that means that if we square this, we're left with x squared plus 2 square root of b plus b squared, plus b is equal to 0. Okay, now what we do is we compare. We have an x squared there. We have a is equal to 2 square root of b, and these two are equal already. Okay, so this I'm going to call equation 1. Now I'm going to do exactly the same thing with the next equation. The next equation was x squared plus bx plus a. So x squared plus bx plus a is equal to 0. Again, we know that it has to be a perfect square, therefore x plus the square root of a must equal 0, all of that squared. So that means we have x squared plus 2 square root of ax plus a is equal to 0. Now we're going to compare again. We have x squared, that's fine. B is equal to 2 times the square root of a, and a is equal. Okay, and this I'm going to call equation 2. Okay, now I've got two equations, two unknowns, so I can solve this quite easily. Okay, so let's see, let's square equation 1. So what we're left with is a squared equals 4b. So that means that b is equal to a squared over 4. And therefore, I'm going to multiply that into there. And then what we're left with is I can replace b with a squared over 4 is equal to 2 times the square root of a. Okay, multiply that up, so that means we're left with this right here. Square root of a. Okay, take this square root of a is actually a to the power of a half, so I can take that across, or I can divide by it. So what I'm left with is a to the power of 3 over 2 is equal to 8. Okay, now I want to solve for a, right? So what I have to multiply by, or I'm going to put it to the power of the inverse of this, which is going to be to the power of 2 over 3, and therefore I have to take the other side and put it to the power of 2 over 3 as well. Okay, so these cancel and these cancel, so I'm left with a is equal to 2, and this is 2 cubed. 8 is 2 cubed to the power of 2 over 3. These cancel, so that's equal to 2 squared, which is just 4. So therefore, I know that a is equal to 4. Now all I need to do is find an equation for b. I can use equation 2. So using 2, I get that b equals the 2 times the square root of 4, which is equal to 2 times 2, which is equal to 4. So b is equal to 4 as well. So we've solved for a and b. And that is the end of that question. And we get 7 marks. So that's quite an interesting question. Let's just go over the logic once again. So basically in the question we were told, we've been given two equations, and we've been told that they both have real and equal roots. Okay, so for real and equal roots, we know that the quadratic must have a perfect square solution. So then we have the two equations, and we know that for a perfect square, it's just the first thing squared or square rooted plus the second thing square rooted. So x plus the square root of b, and all of that squared. Then we squared that to get an expression, and then we equated the expressions. Okay, then we did that for the second equation, and then we equated as well. Okay, so I know that the logic here might not be so straightforward, but once you understand that this opening statement, let's see if I can get a highlighter, once you understand this part right here, so if you're still struggling with this question, try and understand the logic here, and then it should make a bit more sense. But thanks for watching, guys. I hope this video helped you guys. Yeah.